Hello, good day viewers. In this tutorial, I'm going to show you two simple ways to solve double absolute value inequalities. So we have a very simple problem here, which is the absolute value of x plus 1 greater or equal to the absolute value of x minus 3. So let's start with this one. First of all, I would like to determine the zeros of these functions, x plus 1 and x minus 3. So if you set them to be equal to 0, the first one would be x equal to -1, and the second one would be x equal to 3. So I would like to form three different intervals. The first one, on the number line, this is less than this. So I would like to start from -infinity down to -1, excluding -1. So we have something like this, -infinity down to -1, excluding -1. Then secondly, I would like to take from -1 inclusive down to +3, exclusive. Then the last interval would be from 3 inclusive down to +infinity. All right. So what will be the sign of x plus 1 if I should replace x with any value from -infinity down to -1, excluding -1, meaning all values less than -1. Any value you take here that is less than -1, you replace it with this one. For example, -2. -2 plus 1 will be -1, right? So all those values will transform x plus 1 to be negative. So we have negative version of x plus 1 right here. But what will happen to this one if we should take values from -infinity down to -1? All those values will be negative, and negative is still negative, right? So x minus 3 will be negative. So I will have negative version of x minus 3 right here. Then coming to this one, even if it is 0, we are going to set it as positive, right? So -1, since it is included here, it will make this one positive. And any value greater than that, for example, 0, 0 plus 1 is positive, 2 plus 1 is positive. All these values will transform x plus 1 to be positive. So we have positive version of x plus 1 here. So what about this one? If we should plug in any value here, that is less than 3 down to -1, or from -1 down to any value less than 3. If we should plug -1, since it is included, -1, -3 will be -4, right? So all those values will make it negative. So we have negative version of x minus 3 right here. And lastly, we are talking about values greater or equal to 3. It will transform the two functions to be positive. We have x plus 1, we also have x minus 3. So now let us take these three conditions. We are going to start with this one. Remember that our inequality is greater or equal to. All right, let's start with this one. I would like to distribute this first. Negative times x is negative x. 1 times -1 is -1. So we have negative x, -1 greater or equal to this one. Let's expand. We have negative x, then plus 3. Taking this one backward, it becomes positive, and negative x plus x will be 0, right? So we have 0 greater or equal to, take this one to the other side, it becomes positive. 3 plus 1 is 4, and this statement is not true, right? This is false. Then we move to the other one, which is this one. We have x plus 1 greater or equal to, let us distribute this negative, it will become negative x plus 3. Take this one backward, it becomes positive. X plus x is 2x greater or equal to. Take this one to the other side, it becomes negative. Then 3 minus 1 is 2. Divide both sides by 2. We have x greater or equal to 1. But you have to confirm whether this is within the interval x greater than 1. Yeah, x greater or equal to 1 is between this, definitely, because we have 0, we have 1, we have 2, all these values. So you can see that it is what, from 1 down to 3 excluding 3. So let's move to the last one, which is this one. All of them are positive, so x plus 1 greater than x minus 3. X plus 1 greater or equal to x minus 3. Take this one backward, it becomes negative x minus x is 0 greater or equal to, take this one to the other side, it becomes negative 3, negative 1 is negative 4. But this statement is true, meaning that all values of x will satisfy this inequality. So we can say that x belongs to the set of all real numbers. So now let us look at it critically. On the number line, from negative infinity down to positive infinity, if you consider this one all real numbers, meaning it satisfies everything on the number line. But remember, we have another solution, which is x greater or equal to 1. So where can we trace 1? Suppose we have 1 somewhere here. It means that all these values to the right hand side. So if you take the intersection, you can see this is where we have our solution from 1 down to positive infinity. So we can say that the solution to this problem, x greater or equal to 1, and you can also write it in an interval notation as x belongs to the set of values from 1 down to positive infinity. Well, let me show you an alternative. Let me just copy the question. We can replace the absolute value of x plus 1 to be the square root of x plus 1 whole squared, right? This is greater or equal to the square root of x minus 3 whole squared. You can see that the square root will cancel, meaning we have what? X plus 1 squared greater or equal to x minus 3 whole squared. If you want to use difference of two squares, you can take this one backward. So we have x plus 1 whole squared minus x minus 3 whole squared. This is greater or equal to 0. Difference of two squares, what can you remember? If you have a squared minus b squared, this is the same thing as a minus b multiplied by a plus b. So we're going to do the same thing here. All right, since we are subtracting, we have x minus x, which is 0. Then 1 minus 3 is plus 4. Then we multiplied by, this time around we are going to add x plus x will give us 2x. Then 1 plus minus 3 is minus 2. This is greater or equal to 0. 0 plus 4 is 4, and we can divide both sides by the 4. So we have only 2x minus 2 greater or equal to 0. If you take negative 2 to the other side, we have 2x greater or equal to positive 2. Divide both sides by 2, we have x greater or equal to 1. And this is our solution, remember, which you can write in an interval notation as x belongs to the set of values from 1 down to positive infinity. As simple as that. So this is just the first one. Subsequently, we are going to solve as many as possible. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.